We need to understand how to perform binary addition, as well as explain what is meant by overflow, so we'll cover that now. Now there's only 4 rules of addition that exist that we would need to program into a processor for binary. That's different from denary numbers, where you could have all of these combinations of 0 plus 0, 0 plus 1, 0 plus 2, 0 plus 3, for all the pattern all the way up to 9 plus 0, 9 plus 1, and there's lots and lots and lots of. But for binary it's nice and simple. We only need to know the result of 4. 0 plus 0 gives us 0. 0 plus 1 gives us 1. 1 plus 0 gives us 1. And 1 plus 1 gives us 2. And 2 in binary is 1, 0. Now what I've done there is I've marked it beneath the line. You may remember from your math lessons of doing carryover, so what it actually produces is 1, 0. Now this part here is different. We've had 1-bit number, 1-bit number, 1-bit number here, and all of a sudden we have 2-bit numbers. And we'll come back to that when we talk about overflow in a minute or so. Okay, so performing binary addition, let's just stick to smaller numbers. Let's add this number plus this number. So let's just do some quick math to check out our results. So we have 11 and we're adding on 2. So we're hoping the result's 13. So if we take each column at a time, just like we do with real addition, normal addition and denary, 1 plus 0 from our rules is 1. 1 plus 1 is 2, so we put a 0 and the 1 below. So there's a binary 2 if you look at it that way. Then the next column, 0 plus 0 plus 1 is 1. 1 plus 0 is 1. And if we add up all of our places, 1, 2, 4 and 8, forgetting the 2 obviously, then hopefully you know that that adds up to 13. Let's try with another number now, so we'll just stick to 4 bits, just for speed really. So let's add 0, 1, 1, 1, which is 7, and we'll add 7 to that as well, so we can see some trickier maths here. So 7 plus 7 we know is going to be 14. So applying our rules of addition, we have 1 plus 1 to give us 2. And here's a trickier one that we haven't actually seen yet. We've got 1 plus 1, which we know is going to give us 1 with a carryover of 0. But then we have another 1. So what we actually get there is the result 3 really. And hopefully you can work out in binary that that is 1, 1. And that's really the only scenarios that we would have there to deal with. You'd never be able to add more than those number of bits. Now we have the same idea again happening here. 1 plus 1 gives us the 2 with the carryover plus that additional 1 bit. Gives us 1 here again, and we've used our carryover. 0 plus 0 is 0 plus the carryover is 1. And adding up our placeholders, 8 plus 4 is 12 plus 2 to give us 14. Now we mentioned overflow, so I'll just do a nibble right now. Now hopefully you know the range of numbers that can be represented here as 2 to the power 4, which is 16. Now that's 0 to 15 that can be represented. So if we try adding 8 and 8, so let's add 8 here and adding 8 on, so we know that's going to be 16, which is out of the range of our number. So if we've only got 4 bits that we can write down, 0 plus 0, 0, 0 plus 0, 0, 0 plus 0, 0. 1 plus 1 gives us 2 with the carryover. Now what we need here is a 5th bit, but because we are saying we only can store a nibble, we can't actually store that. So this is where we get an overflow error occurring, where the range of numbers is limited and the result of a calculation, or the number that we wish to store, goes over the range that can actually be stored by that number. Now these are really simple once you get the hang of it, and I would suggest that you spend a lot of time practicing some simple addition. Convert the numbers to their denary equivalent, work out what your result should be, and then have a practice at them.